Hello dear students of plus one, medical, non-medical, respected teachers and dear friends. Today I am going to discuss the principle of a refrigerator or simply known as fridge. It is also called a heat pump. Now, it works upon the principle just a Carnot cycle or heat engine working in the reverse direction. It is the inverse of, you can say, Carnot cycle. The main parts of a refrigerator are number one, sink, T2 Kelvin, known as cold reservoir of heat, source held at T1 Kelvin, called hot reservoir of heat, and working substance, which is in the gaseous state, freon gas is used in the compressor, and there is electric motor or compressor. Electric motor or compressor. Because in this case, in case of fridge, amount of heat drawn from the sink which is at lower temperature than the surroundings, and it is impossible to draw heat from a body at lower temperature to a body at higher temperature without the aid of supply of energy or without external work, because in natural way heat always flow from a body at higher temperature to a body at low temperature. But when we have to draw heat from a body at low temperature and transfer it to a higher temperature, work has to be done, and which is done by the compressor or electric motor. Electric energy supplied to the compressor, so works to supply this energy to remove heat from the sink. So what happens? Suppose Q2 is the amount of heat taken away from the sink, that is from inside the fridge. Now, W is the amount of work done upon the system in order to transfer to take heat from sink. Then whole heat is transferred to the source. That Q1 the amount of heat rejected to the source, that is the room, atmosphere outside the fridge. Then by conservation of energy, you can say that Q2 plus W must be equal to Q1, or W is equal to Q1 minus Q2. It is amount of work done by the external motor or fridge is equal to difference in temperature, difference in heat taken or rejected to the source. Also, if you use differential form of first law of thermodynamics, dq is equal to du plus dw. In this case, du is 0 because it is a cyclic process. System turns back to the initial state after completing a cycle, and this process is repeated again and again. So in this case, there is no change in internal energy of the system. Therefore, du 0 or dq is equal to dw. Means difference in heat, that is Q1 minus Q2, is equal to amount of work done by the motor or the compressor. So, to define its efficiency, we define coefficient of performance of the refrigerator. So, let beta is equal to coefficient of performance of the refrigerator. Then beta is defined as the ratio of amount of heat removed from the fridge sink, that is from inside the fridge, divided by amount of work done in order to do so by the compressor or the electric motor. So beta is equal to Q2 upon W, amount of heat removed from sink, from fridge inside, and amount of work done in order to do so. So beta is equal to Q2 upon W, or Q2 upon Q1 minus Q2, or divided by Q1. Denominator and denominators we have Q2 upon Q1, Q1 upon Q1 minus Q2 upon Q1. Or we have in coordinate cycle, we have proved Q2 upon Q1 is equal to T2 upon T1. So therefore, beta is equal to T2 upon T1, 1 minus T2 upon T1. Or beta is equal to T2 upon T1 minus T2, which is the required expression for coefficient of performance of the refrigerator. More is the value of beta, more is the efficiency of the refrigerator. So coefficient of performance determine the efficiency of the refrigerator. So for beta to be large, for fridge to be more efficient, T1 minus T2 should be as small as possible. That is difference in the objects placed inside the temperature of the objects placed inside the fridge and outside the fridge, that is room. Difference in temperature, room temperature difference should be small. That's why when we have to cool some object, some food, water, and we should place it in the fridge after cooling it to a temperature just equal to the room temperature. So that its coefficient of performance is more, efficiency is more. So for large beta, T1 minus T2 should be as small as possible. So beta is always greater than 1. So beta should be greater than 1 for better performance. And if we take efficiency of Carnot cycle or any heat engine, eta is given by eta is equal to 1 minus T2 upon T1. Therefore, 1 minus eta is equal to T2 upon T1. If we substitute these values in this equation, T2 upon T1 minus T2 or this equation, so we have beta is equal to 1 minus eta upon eta. So this is the relation between coefficient of performance of a fridge as well as Carnot cycle or heat engine, how they are related to each other. So efficiency of Carnot cycle or any heat engine is always less than 1, but beta is always greater than 1. So from this equation or from this equation, beta is equal to T2 upon T1 minus T2, we have some questions and we can answer them by knowing this equation. First, it is very clear that beta gives the efficiency of a fridge. More is beta, more is the efficiency. And for beta to be large, T1 minus T2 should be as small as possible. That is, difference in temperature inside the fridge as well as outside the fridge should be as small as possible, so that its efficiency is more. Then for beta to be large, T1 minus T2 should be small. It means as objects inside the fridge cools down with the passage of time, T2 decreases. And due to the formation of ice, T2 becomes almost constant. Then beta decreases. So that's why defrosting of the fridge is very, very important. It is must. So we have to defrost our fridge with a lot of ice inside the fridge. So defrosting is very, very important, because if we don't defrost, beta will decrease as the efficiency of your fridge will decrease. So it will get damaged soon. So defrosting is why, question is why defrosting is necessary. Because when there is lot of ice forms inside the fridge or freezer, then beta decreases. So to increase beta, to increase the efficiency of fridge, we have to defrost it. So nowadays the fridges, all fridges are automatically defrosted continuously, and in early days it was defrosted by using a manual button. So defrosting is must. Now for beta to be infinity, work done should be 0. but which it is impossible. So coefficient of performance of fridge can never be infinite. So why efficiency or beta of a fridge can never be infinite? Because W for that, for beta to be infinite, W should be 0, which is impossible. So that's why beta can never be infinite. So there is one more question. Suppose fridge is working in your room, and when door of fridge remains open, open the door of fridge and leave it for long time. What will happen to the temperature of room? Some students sometimes answer room will get cold, temperature will fall. No. When door of the fridge is kept open for a long time, temperature of the room will increase because compressor or motor has to do more work to draw more heat from inside the fridge, because that send it outside, and then again hot air enters the fridge, so compressor has to more work again and again. As a result, temperature of the room will increase. So when door of the fridge is kept open, temperature of the room will increase. One question. Number two, defrosting is must. Number three, for more efficiency, difference in temperature inside the fridge and outside the fridge. That is, objects placed inside the fridge, maybe milk, water. Never put hot milk inside the fridge. It will decrease beta. So we have to make the milk cool, just equal to room temperature, then put it inside the fridge, then it will get cold. So these are the main questions related to principle of refrigerator. So it means principle of refrigerator works on second law of thermodynamics, not first law, because second law of thermodynamics states that it is impossible to draw continuous supply of energy from a body at low temperature to a body at high temperature without the aid of supply of energy. Work has to be done by the external agency. This is second law of thermodynamics. So fridge works on principle of second law of thermodynamics also. So this is all about fridge heat pump. It is also called heat pump because it pumps out heat from inside the fridge and temperature of the room will increases. That's why it's called heat pump. So refrigerator, our air conditioners, heat pumps, all use this principle. So in the next video, I'm going to discuss a very, very important full article on the basis of Carnot cycle or ideal reversible heat engine, and I will drive its expression for its efficiency. So till then, stay tuned, be happy, good luck, all the best.